I'm Shannon Tato, and welcome to my YouTube channel. Now, it has been a little while since I posted an update to my initial theory videos, but that was mainly because I just didn't know where to go from where I left off. But thankfully I figured that out, and the good thing is that this video has some of the most compelling evidence to proving my theory of any video that I've made yet. But that then begs the question, what exactly is going on in this video? And to that, I have an answer for you. Now, here we're going to be talking about, as it says, combustion ionic hybridization of rocket thrusters. Now, what exactly is that? Great question. Now, one of the things I never actually really talked about in my main theory videos is what an actual rocket thruster capable of moving a ship close to the speed of light look like. And that's what I'm going to talk about here. Now, as you may know, if you've seen my initial theory videos, that in my theory, the idea is that if the molecule enters an ion thruster already in motion, it'll accelerate exponentially faster than it would have if it had close to no velocity at all when it initially entered the ion thruster. So that's where this idea comes in, the idea for creating a combustion ionic hybrid rocket. Now, a combustion ionic hybrid rocket is as simple as it kind of sounds. It's essentially just an ion thruster strapped onto a combustion rocket. Your typical combustion rocket consuming liquid hydrogen and liquid oxygen, combusting, creating thrust, accelerating forward, which would then be accelerated again by the ion thruster. Fairly simple, but also not simple if you go into more technicalities about it. One of the biggest issues with this being that combustion rocket thrust, or exhaust, is very, very hot, meaning that they need to have a very complex cooling system. That's why the nozzle of most combustion rockets are cooled by pumping liquid hydrogen across it, or whatever liquid fuel they're using, which is usually really, really cold. Same thing applies for the ion thruster. The ion thruster will have liquid oxygen pumping across it, but the big thing is, of course, this middle bar. Now, these little spikes here are the anodes, and the top pieces are the cathodes, and arcs jump between them, and they propel forward. Now, this is one of the most complex parts of the actual rocket itself, which is why I have a more in-depth diagram down here. Now, here I have a more in-depth diagram what actually goes on. Liquid oxygen is pumped into this center part here, and it's shot out through these little tubules. They then shoot the liquid oxygen out onto the surface area around the little centerpiece just for maximum cooling efficiency. Fairly simple. There are also these little shrouds which come up around and block and protect the anode from the incoming hot gases. These will also have to have pipes through them to cool them, otherwise they would probably melt because they're thinner. There's also a very strong vacuum which is pulling the oxygen out about just as fast as it's being pumped in, just to make sure everything keeps circulating and to keep pressure from building up too much. There's also going to be liquid oxygen pumping in through these supports. Now, they don't really serve any purpose pumping liquid oxygen through, but the reason they do is to keep them cool, because if these supports didn't do that, they would probably melt inside of the thruster. I also have a more close-up here of the actual anode itself. You see here you have a wire, which is going to be coming through a little pipe in connecting up to the copper anode, and you have the shroud here. You can see the pipe where the liquid oxygen will be circulated through, and it shows where the gases will be flowing, and eventually they will hit the arc and they'll accelerate forward. Now, the thing about it is that fiberglass can be placed between the steel boundaries of the little container and the actual anode itself. The reason that insulation, you don't want to have this be electrically charged, because if you did, then the whole thruster would be electrically charged, and then everything would short, and it would just cause a big mess. But another interesting thing that needs to be used is, you may notice it says quartz glass screws. These screws are there to hold the anode in place, and the reason they need to be quartz glass is because it's not conductive, and it's highly temperature resistant. And that's essentially the gist of it. Now, I do plan on making an episode 4 where I go into more depth on everything over here, because there are quite a few more details that need to be addressed. But for the sake of time, I don't really want to address them all in this video. But with all that said, I think it's time we move on to the next one. I then started by calling back up the fine Chinese sweatshop that sold me the electronics components that broke after one use. I was noticeably disappointed in their response. Thankfully, though, I ordered a new pair of electronics components for another $12 that was soon to arrive. The package arrived abruptly, to say the least. Turns out the Chinese sweatshop wasn't happy with my complaint. Thankfully, though, I was alright, but unfortunately, whilst working on the prototype and a few too many swigs of chloroform, I woke up in the woods. Now, for reference, I'm going to use the same method as I did in the first video, which is with a piece of tape. I'm then going to place the piece of tape in front of the moving ion thruster to show the airflow being generated as a result. Now, the thing is, this is just an ion thruster. We don't have any source of initial airflow coming in yet. And that's where the next part comes in. A fan. Now, to start off, I'm going to dim the light over here a little bit, and then I'm going to activate the fan. Now, if I place the tape in front of the moving airflow here, you can see it bending back a little bit to see the airflow. Now, this is just from the fan. Now, if I were to actually go and activate the ion thruster while this is running like this, you can see an immediate difference. The tape starts flying back a lot more than it did before. So now if I deactivate the ion thruster, you can see it immediately drop. These are all, of course, good results. So with all that said, I personally find that that experiment to be fairly good evidence towards my theory. And with that, I hope I can continue advancing and making better ion thrusters to use as examples with hopefully more materials in the future to then get an even better view into whether my theory is correct or not. So with all that said, I do like to give a little follow-up onto videos that I plan on doing in the future. And my next video that I plan on doing is another music video, which you'll find out about hopefully soon. And of course, as I said earlier, I do want to make an episode 4 where I go into more detail on all the funny pictures behind me, which hopefully will be coming out fairly soon after the next music video that I make. But with that, that's pretty much it. Thanks for watching. Remember to like and subscribe, and that's pretty much it.